Yes, so good morning, everybody. Today we are going to learn the topic that is rank correlation. Rank correlation. First, we need to know what the correlation word suggests. When in statistics, whenever we will be having bivariate data in statistics, that means the variables having the category X and some variables are false in the category Y. So if you have the bivariate data, there must be some association between these two variables, between these two entities, right? In the statistical data, whichever is given to us. So that association between these two variables, or you can say the degree of association between the two variables given in the bivariate data, that will be learned, or that will be measured by, or that will be termed as correlation between these variables. So the correlation word suggests the degree of association between the variables. Degree of association, how much the two variables are associated with each other. So that degree of association is done by the word, or is known as the word correlation. This correlation is the degree of association between the variables X and Y whenever a bivariate data is given to us. So now, how we are going to measure it then, how much they are associated, where there is a strong association between them or there is a poor association between these variables. So we must have some measure to get the amount of association, or extent of association rather, you can say, between these two variables. So that measure is done by the term that is correlation coefficient. Correlation coefficient in statistics. It is usually be denoted by rho. So we have learned earlier also, whenever we have done the topic, the correlation, the thing. So this is correlation coefficient, which is denoted at the word rho. So correlation coefficient is what? It is the measure of degree of association. It gives the measure by which we can get the amount of association or the extent of association between the two variables in a bivariate data. That will be done by the correlation coefficient. Now comes to the word. Today our topic is rather rank correlation. Rank correlation. Correlation, what the word suggests, that we have just now seen. Now what is this rank? Rank means whenever there is a quality between the two variables, if the qualitative measures are given over there regarding to these two variables, then that quality may be ranked from 1, 2, 3, 4, like this. So rank, we can give the rank to these qualities whichever is given as the variables in X and Y, right? So these qualities are given to us in the variables X and Y. So whenever we take the rank, so rank suggests the ranking of the quality which the variables are denoting. Okay, so now the total word rank correlation, that means first we need to give the ranks to the qualitative entries whichever is given to us as the two variables, and then we can found the relation, rather correlation between these two qualities. Okay, so after giving the rank, we will be getting the correlation between these two variables. So that is known as the rank correlation. Now we will be taking a particular example where we are going to find out the rank correlation between the two variables. So let us go through a note. I'm going to a note where we are going to do some practical examples which will allow us, or which will move for take on to us to the for finding the rank correlation between the qualities. So if you can see the notes over here, you can see that I'm denoting X as the beauty of girls. X is the variables denoting some beauty of girls, and Y denotes the intelligence level of the girls. Okay, and that table is shown over here. So intelligence level is given in numerics, and the beauty of girls is given as the 10 girls. And then also we have ranking them according to their beauties. Some girl had got the given rank 1, 2, 3, 4, 5, 6. So in this case, whatever the tabular form we can see, you can see from here, that is the beauty rank. First, the X variable, which is denoting the beauty rank. Y is the rank according to their intelligence given to these girls. And then we have found the rank correlation coefficient between these two variables, X and Y. And that expression to obtain the rank correlation coefficient, or rather you can say the formula to obtain the rank correlation coefficient between the two variables are 1 minus 6 into summation d square divided by n cube minus n. Now, what does this D stands for? D stands for the difference of the corresponding rank for a particular individual, or for a particular entry. And n denotes the total number of entries are there in the variables in the data, total number of variable entries, or rather you can say total number of individuals are considered in the data whichever is given to us. Now let us take a particular example where we are going to find this rank correlation utilizing this formula. So how we need to proceed, that let us see. So let us take this particular problem. See, in a beauty competition, two judges are there, 1 and 2. Rank the 12 entries as follows. Find the rank correlation coefficient between the judgment of two judges. Okay, so there are 12 entries, means 12 competitors are there. And there are two judges, one is judge 1 and judge 2. So 12 competitors are there, and the judges given their decisions, given the ranks to those 12 competitors. Judge 1 has given according to him, Judge 2 has given according to him, and then we need to interpret that the rank correlation between the judgment. So how much the judgment of these two judges are correlated to each other, or they are at all not at all correlated. Okay, so that interpretation we need to do over here. So let us write the data at first in the whiteboard. And then we need to proceed for doing the rank, or rather you can say for finding the rank correlation coefficient between the variables. So I am writing the data at first. Let me go to the whiteboard. Yes, here it is. So I'm clearing the previous part. So what the problem is, there are two judges, X. Let judge 1, the rank given by judge 1 is X. Rank given by judge 2 is Y. Judge 2 is Y. And the total number of individuals or total number of participants in this case is 12. So the rank that judge 1 has given through all these 12 entries, that is 1, 2, say 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And accordingly, the first person, according to judge 2, has given the rank as 12. The second person, according to judge 2, has given the rank 9. Then it is 6. Then it is 10. Then 3. Then 5, 4, 7, 8, 2, 11, 1. All right. So these are the ranks that two judges has given to the 12 participants. Now we are going to interpret the judgment, the correlation between the judgment of the two judges by finding the rank correlation between these ranks. So let us do the interpretation. For finding the rank correlation, as we know, the formula is for rank correlation 1 minus 6 summation d square divided by n cube minus n. So what it is? D first we need to find. So D is the difference in their rank. The absolute value of the difference in their rank will be given as D. So D is for the first case it is 11, then it is 7, then it is 6 minus 3, that is 3, 10 minus 4, 6, 5 minus 3, 2, then 1, then 3, then again 1, then 1, then 10 minus 2 it is 8, 11 minus 11 it is 0, and 12 minus 1 it is 11. So like this we have got D, and N is already there with us. So what is the requirement? Next requirement, that is D square, because we need to find out the summation of the table D square. So D square means for 11 square it is 121, then 49, then 9, 36, 4, 1, 9, 1, 1, 64, 0, 121. All right. So we have got D square. Now, if you sum up this table, you will be getting summation D square. So summation D square, if you sum it up, you will be getting it as 416. You can check it out. Okay. So we have got all the entries according to our formula. So rank correlation will be rank correlation between the two judges is equals to 1 minus 6 into summation D square means 416 divided by n is 12. So 12 cube minus 12. And it will be obtained as, if you evaluate, it is with a negative value, minus 0.4545. So we can see that the rank correlation between the two judges is negative. All we know from the previous part, or from the knowledge of correlation, that correlation will always, rather you can say the measure of correlation will always lying between -1 to 1. Now we have got, for this case, the correlation is minus of 0.4545. Negative correlation between the judgment of two judges. So what will be the conclusion, or what will be our interpretation? Since they are negatively, two judges are negatively correlated, that means if we can interpret from here that the rank given by the judge 1 is higher, then there is a tendency that rank given by, if the rank given by the judge 1 is higher for a particular candidate, then for that particular candidate, rank given by judge 2 will be lower. That means they have some oppositions according to their judgment. Their judgment are not uniform, or their judgment are not strongly related or correlated to each other. You can say they are almost they have a very less poor correlation between them. That means if the if judge 1 is selecting a person as a better one, then that person will be considered to be as not that better according to the judgment given by the judge 2. Okay, so this is our interpretation according to the rank correlation we have got. So in this way, in a particular problem, by finding the rank correlation, we can find that the two variables, or the two ranks, two qualitative ranks, how they are correlated to each other. If we are getting a positive value, then there will be a we can say a little bit better correlation between the variables, or between the qualitative ranks. And if we are getting a negative value, then there is a opposite correlation. That means there is a poor correlation between the two ranks or two qualitative entries, whichever is given in the data. So this is how we are going to evaluate if the rank, if the qualitative rank is given to us as the statistical data. Now, in the next problem, I'm moving on to a next problem where we can see that some qualitative entries, some qualities, some marks according to the qualities are given to us. And then we need to make the rank. We need to find the rank corresponding to those qualities. And after finding the rank, we need to proceed for the rank correlation. Likewise, in this particular problem, from the very first data, as X and Y, it is given to us in the form of a rank. But if the data is not given to you in the form of a rank, but rather it is given to you as a quality, then we can first denote or first make the rank corresponding to the quality, corresponding to the score, like this. And then after assigning the ranks to that particular quality of the particular individual, we can move on to the rank correlation. So likewise, we will be taking the next problem, in which first we need to find out the rank and then we need to proceed for finding the rank correlation. So this is our first problem where we have found the rank correlation. Yes. Now look at this particular problem, in which we need to assign the rank at first and then only we can find the rank correlation between the variables. So let us read out the problem at first. In a class, 10 students obtain the following marks in mathematics and physics out of 100. So the marks obtained by 10 students are given over here in the subject of mathematics and physics out of 100. So the first student, according to the data, look at the data, mathematics, marks in mathematics, and then marks in physics. So first student has obtained 8 in mathematics, 84 in physics. Second student 36 in mathematics and 51 in physics. Third student likewise 98 in mathematics and 91 in physics. Seems to have a good student. And then for 25, the next student is getting 25 in mathematics and 16 physics. So likewise, the marks in maths and physics are given over there as the data. Now, what we need to do is we need to find the rank correlation coefficient of the marks obtained in these two subjects. So here, the ranks are not assigned at all. What we need to do is we need to first assign the ranks corresponding to their scores in maths and physics, and then we need to proceed for finding the rank correlation coefficient between the two subjects. So let us move on to that. So I'm going to the whiteboard, and where first I'll take this data, and then we will assign the rank, and then we will proceed for the rank correlation as we have done in the previous problem. So let us go to the whiteboard where I need to jot down or get the gist of the problem. Yes. So I'm clearing this one as this is our previous problem. Yes. Now in problem number 2, in rank correlation coefficient. So what is given to us? Some marks obtained by 10 students in mathematics and physics. So let us write down the marks. Maths and then marks obtained in physics. So the first student have got 8 in maths and 84 in physics. Next student have got 36, 51. 36 in maths, 51 in physics. Next student 98, 91 seems to be a good student, as I said, 98, 91. And next is 25, 60. Then next student 75, 68. 75, 68. Next one has got 82, 62. 82, 62. Next one 92, 86. Again a good student. 92. 86, no, yes, 92, 86. Next one is 62, 58. Some average students are also there. 62, 58, and then 65, 35, 65, 35. And next and the last one has got 35, 49. 35, 49. So these are the marks obtained by the 10 students in maths and physics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 and 11. Now we need to assign them rank. Rank in maths. Let it be denoted as X. Okay. So look at the highest marks in mathematics, that is 98. So corresponding to 98, the rank will be 1. The next highest is, I think, 92. So corresponding to 92, the rank will be 2. And after 92, the next highest is 82. So corresponding to 82, it will be 3. Corresponding to 82, it will be 3. Then after 82, it will be 75. So corresponding to 75, it is 4. And then it is 65. 65 had got 5. Then it is 62, 6. And 62, then 35. 62 is 6. Then 50. 36, more than 35. So it got 6. Then 7. No, 35. 5. 35. More than 35 is 36. So 65. Corresponding to 65, it is 5. Then 62, it is 6. So 6 has already assigned. So it will be 7. Yes. And then 35, it will be 8. Then 25, it is 9. And then 8, it is 10. So these are the ranks that we have provided, that we have given according to their scores in maths. Similarly, we need to give the rank according to their scores in physics, and let it denoted by Y. So in physics, the highest marks it is obtained is 91, so it got 1. Then the next highest after 91 is 86, so it will be 2. Then after 86, it will be 84, so it got 3. 84, no 7 rank is there. So 4 will be corresponding to 68, I think. 4, then 62 will get 5. Then after 62, I think it will be 58. So it is getting 6. Then, no, after 62, it is 60 is also there. So it will be 6 and 58 is 7. Okay. And before 58, it will be 51, I think. Then it will assigned as 8. Before 51, it will be 49, which is 9. And before 49, it will be 35, that is 10. So likewise, the ranks given in X and Y are given. So we have obtained the rank now. Now the procedure is as similar as we have done for the previous problem, that according to the formula, we need to have over here 1 minus 6 summation d squared divided by n cube minus n. So D is what? D is again the difference in rank, the absolute difference in rank. So mod of X minus Y. And it will be obtained as 10 minus 3. It is 7, 1, 0, 3, 0, 2, 0, 1, 5, 1. So likewise, we have obtained and summation d square. That means d square is again required. So let it make it d square. It will be 49, 1, 0, 9, 0, 4, sorry, 4, 0, then 1, then 25, and then again 1. And summation d square, if you obtain the sum of this column, will gives us 90. So all the things are done. Now we can find the rank correlation. That is, the value of rank correlation would be 1 minus 6 into summation d square means 90 divided by n cube minus n, that is 10 cube minus 10. And it will be evaluated as 0.455. So positively correlated, that means they have a good association between them, since it is positively correlated. As we have seen, they are correlated at all to each other. Those who have got good in physics, they have got good in maths as well. This estimate can be done, or this interpretation can be done from this particular value of the rank correlation. It is not the case that each and every one of the candidate, those who are getting good in physics, they must get in good in maths, but it will be for most of the cases that they are maintaining a positive correlation between the marks in maths as well as the marks in physics. Positive correlation between them. As one is increasing, then another is also increasing. As we know that it is an increasing, likewise it will be going on in increasing functions. If x increase, y will also increase whenever there is a relation between x and y. So like this, we have got a positive rank correlation between the variables, or between the ranks, or between the students, whichever is there. Okay, individuals. Now, again, I'm going to take next problem, in which in this particular problem we have assigned the rank. But if you can see, the marks obtained by each and every particular member is different. They have some, they all have, rather you can say, distinct marks. But instead of that, if some particular students get the same score, then what will be the rank to be assigned corresponding to them? Say 3 students have got 90 in maths, okay, and highest marks is 98, as you can say, and 3 students have got 98. So which one has given the rank 1? Or what will be the rank corresponding to all these 3 students, because they have got the same marks? So that interpretation will be done in a bit different way, and that we are going to consider in our next problem, which will allow us to obtain the rank correlation when there is a tie rank in a series of data. That means the rank is getting tied. Some persons have getting the same scores or same qualities among the individuals. Then what we need to do, that will be check out in our next problem. So let me go to the next problem, and then we will proceed. Yes. Now you can see in the screen that which says that the rank correlation when there is a tie rank in any series. That means, as I told you, that if more than one individuals are there, which those who are having the same rank, then what will be the rank, actual rank assigned to all of them? The rank which will be assigned to each of the individuals having the tie rank between them, that will be the average of the ranks they are getting according to their sequence. That means R, if R is the tie rank among the k individuals, then we will take it as R, R plus 1, R plus 2, likewise up to R plus k minus 1 divided by k if there are k number of individuals which is having the tie rank R. Now let us check out a particular problem, then it will be easier to us to get the clarification. Look at the problem. In the following table are recorded data showing the test scores obtained test scores made by the 10 salesmen as an intelligence test and their weekly sales. So two scores are given over there, rather two entries are given over there according to the 10 salesmen. One is a test scores, okay, according to their intelligence. There will be a test given there, they have assigned to a test, and the scores they have obtained according to their intelligence test, that is given to us for the 10 individuals. And then sales they have made in rupees, rather in thousands rupees, of these 10 individuals, that is given as the another variable. So what we need to do is we need to find the rank correlation between the intelligence and efficiency of the salesman. Okay, salesmanship, rather efficiency in salesmanship for the 10 individuals. So let us do that. And you can see, if you can see from the data that here we have tie ranks. That means scores. Some individuals are having the same scores according to their intelligence test as well as according to their salesmanship. Like the salesman 1 and 3, 1, 3, 6, 8. All of them have scores 50. Test scores. Intelligence, according to intelligence test, they score 50. Likewise, the others are also there. Okay, so what or how we need to proceed for these ranks, that we need to check it on. So let us proceed. First, let me go to the whiteboard where I need to input this data, and then we need to proceed for assigning ranks, and then we are going to find the rank correlation. So let me go to the whiteboard at first. Yes. Clearing the previous data as we have done already that problem. Yes. So what the problem says, there are 10 salesmen and then test score according to their intelligence, and then you have obtained the this sales. Let a column be blank to make the rank for these test scores, otherwise it will be difficult, and let it be denoted as X. And then the another category which is given, that is sales in 1000 rupees made by them. Sales in 1000 rupees. And let the next column will be rank, that I am denoting it as Y. So 10 individuals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going to write their scores, and then we are going to write the rank according to their scores. So the first score, that is 50, 70, again 50, 60, 80, 50, 90, then 50, 60, 60. Now I am going to assign the ranks according to their scores. The highest score, who have got the highest score, that is 90. I think only 190 is there. So corresponding to 90, I'm writing it as 1, the rank 1. Now next highest is 80. So that is also only one candidate. So it is 2. Next, third rank will be given to, after 80, it is 70. 70. Yes, only 170 is there. So rank is 3. Now fourth rank, 60, 60, 60. 4 candidates are, sorry, 3 candidates are there. Salesman 4, salesman 9, and salesman 10, having the score 60. That is fourth rank. That means they are acquiring 4th, 5th, and 6th. So we are going to take the average of those ranks. That means the rank that will be assigned corresponding to the score 60. That is 4 plus 5 plus 6 divided by 3. Average of all these ranks. Okay, 4th, 5th, and 6th. Okay, so for 4 plus 5 plus 6, the average value will be 5. So we will assign rank 5 to all 60s. 5, 5, and 5. And the next highest is 50. Again, 50 is for 1, 2, 3, 4 candidates. One salesman, 1, 3, 8, 6. 1, 3, 6, 8. So what we need to do it, they will be getting after 7th, rank after 7th. So 7 plus 8 plus 9 plus 10 divided by 4. The score, the rank that will be assigned 15, 15 plus 9, 24, 24 plus 4, 34, 34 divided by 4 is 8.5. So the ranks given to all those 50s as 8.5, 8.5, 8.5, 8.5. So see, all the ranks are assigned. Now we can proceed for writing sales in rupees and then finding the rank corresponding to that sales. So let us write sales in rupees. First is salesman is 25. Then 60, 45, 50, 60, 45, 50, then 45, 20, 55, 45, 20, 55, 30, 45, 30, 30, 45, 30. Now, according to scores, we are assigning the ranks. The highest score that will be over here is 60. So the rank is 1 corresponding to 60. Then it is 55. 55 is only for ones, that is 2. Then it is 50. 50 is again for only one candidate, that is 3. Then it is 45. 45 is for 3 candidate. You can see 45 is getting 3 individuals are getting 45. 1, that means 4th, 5th, 6. So 4 plus 5 plus 6 means 5, the average value. So all 45 will get 5, 5, 5. Next is after 40, before 45, it will be 40 is not there. 30. Yes. Again, 30 is more than 1. 30 have got. So 2 individuals, so 5, it is 4, 5, 6, 7 and 8. The average of 7 and 8, 7 plus 8 divided by 2, that will be 7.5. So all 20 or all 30 have got 7.5, 7.5. And then what it will be, 7, 8 is done. So before 30, it is 25. So 25 has got the rank 9. Then 20 has got the rank 10. So ranking has been done. We need to proceed. Rank has been done. We have got the value of x and y. So the work which is left with, that is d mod of x minus y. So let us do that. Minus 0.5 or 0.5 as we have taken the mod. Then 2. Then 3.5. 2. Then 3. 1.5. 1. 1. 0. 2.5. Now what is the requirement? That is d square. So let us make d square. D square will be 0.25, 4, 12.25, 4, 9, 2.25, 1, 1, 0, 6.25. And sum of the d square will be 40. Okay. So in this way, sum of the d square will be 40. So in this way, we have got all the entries and the corresponding values or corresponding formula for rank correlation in case of tie rank, that is 1 minus 6 summation d square plus summation t cube minus t divided by n divided by n cube minus n. Yes. So for the formula for the rank correlation in this case is summation 6 into summation d square plus summation t cube minus t by 12 divided by n cube minus n. Now what this d, that all we know, d square summation d square, we have got it as 40. And what is t? The number of times the tie has been done. So how many times the first tie has been done for four individuals? For four individuals, as we can say that for the first rank, 8.5, 8.5, 8.5, 8.5. So four individuals having one tie. So we can write it as, we can evaluate it as like this. This will be 1 minus 6 into summation d square is 40 plus. Now this summation will be taken individually. How it is? First tie is with four individuals. So I will write 4 cube minus 4 divided by 12. Then next tie, as we can see, it is with three individuals, that is 5. So 3 cube minus 3 divided by 12. And then the third tie, which is in the series, I think in Y series, that is again for three individuals, 5, 5, and 5. So we can write it over here, 3 cube minus 3 divided by 12. And the next and the last tie, that is with two individuals, that is 7.5, 7.5, you can see from here. So we can write it as 2 cube minus 2 divided by 12. So in this way, all the ties we have considered over here, and we can now put it into the formula, that is divided by n. Now what does this n stands for over here? That is the total number of individuals considered in the statistical data. So the total number of individuals, or rather you can say in this data, they are the salesmen. So that number of individuals is 10. So we will be writing n, we will be taking n as 10, and here the value will be 10 cube minus 10. So whatever the value will come out after evaluating this, you can see it will be 0.70. So the rank correlation we have obtained between the 10 salesmen, which data, whichever is given to us in this statistical data, that is the correlation, rank correlation between their test scores according to their intelligence and the sales they have made in rupees thousands, that is 0.70. As it is more or less nearest to 1, we can say that there is a strong correlation between these two qualities. What these two qualities are? Their intelligence and their salesmanship. So the person who is more intelligent, he is good in salesmanship. The person who is less intelligent, he is that it's not, it is may not be that good in salesmanship. So this data we are interpreting this thing from this data after obtaining the rank correlation. That rank correlation value, as it is nearest to 1. So from the rank correlation, we are interpreting that the test scores or the intelligence is positively, obviously it is positively correlated, and there is a good correlation between these two qualities. So this is all about the rank correlation we have learned today, and we have dealt with various types of problems in that may come out in the topic of rank correlation. Okay, so that's all for today.